biology or perhaps a major that will require chemistry? Almost everyone. Great. Fantastic. How many of you have had high school chemistry? I'm just curious. And 2 semesters or a full year sequence? So what I want to do today is I want to talk to you a little bit. I want to talk to you a little bit about how we structure the course, and what I thought I would do is really kind of walk you through the first lecture that I typically give in 142, which is the first lecture, the first day of Chemistry 142, just to give you an idea of the pace. So this would, at Emory, you would traditionally take this course second semester you're on campus. We don't offer it currently in the fall, so you would take it in the spring of your freshman year. And really, what I want to tell you is, or talk to you about, is what we expect in terms of student commitment and what we expect students to do to be prepared for the course and to excel in the course. And if you've had one of these already, right?
Yeah, you're the first one.
Oh, I'm the first. Okay, I wasn't sure. No pressure. Well, we all approach this a little bit differently, I know. So I did teach this course, Chemistry 142. I did teach it this past spring. And one of the things I want to point out is that in some of these courses, they're a little bit larger. They're larger lecture courses. So there'll be between 100 and 120 students enrolled. So in addition to having just the professor in the class, you'll often have maybe a head TA. And this is the person that they're in graduate school, they're traditionally pursuing their PhD, and their role as the head TA is really to assist the professor with the day-to-day operations of the course. And clearly, if you're enrolled in a class with maybe 100 to 120 students in it, you want to make sure that there's someone available to meet with you and talk with you if you have questions. So this student, the head TA, will also, in addition to the professor, have office hours and allow you to reach out to them. So it's really just kind of doubling, the people available for you to succeed. Okay. So what I traditionally do when I start the course is I introduce myself, and because I don't think I know any of you in this room, I don't think we've met before, I would introduce myself and tell you a little bit about my background. So I received my Bachelor of Science degree from Penn State University. Then I went on to get my PhD at the University of Kansas, Rock Chalk, Ohio, go KU. I'm a huge college basketball fan, but we'll save that discussion for another time. And then I did my postdoctoral work at the California Institute of Technology. So I spent 3 years there as a senior research scientist, at Caltech, in chemistry. I like to tell people a little something personal about myself. Does anybody know what this is? It's a kiwi, and where are kiwis from? New Zealand, right. They're from New Zealand, which is very close to Australia. And the reason I show this as something about myself is I'm married to a Kiwi. And that's what we refer to people from New Zealand as, so he's a Kiwi. The other thing I'll tell you about myself is I have a certain passion for caterpillar leopard dogs. My husband and I, we have a couple of rescues. And this is the state dog of Louisiana. They're very big, but they're beautiful and gorgeous in every way. So Hurricane Katrina that happened in 2005, that's when we got our first dog. And so they're a big part of our life and life outside of Emory. So that's a little bit about myself. So what I would like to do is really talk to you about the nuts and bolts of every course that you're going to take in college. It's going to be laid out in the syllabus. And I have a sample syllabus for you that I'm going to pass on. Drew, you'll share it with all of them.
Absolutely.
But I also have it kind of in PowerPoint format, so we'll just go over what's expected. And Drew will give you a PDF of our syllabus. So the syllabus is going to contain course information. It's also going to tell you course content, what we expect to cover during the course of this semester. It's going to tell you important dates. It's also, on the syllabus, it's going to tell you when all of your exams are. And I just want to let you know right now, I do this on the first day of class when I lecture. The dates are in print. If you have a conflict, I need to know within 36 hours. You cannot wait until the week before the exam and say, oh, I'm running track and I have a track meet. Your coach will have given you that schedule. It's too late. So one of the things that I ask students right off the bat, get those dates for the exams in your calendar, make sure that they're noted, and if you have conflicts, let the professor know right away, okay, so that they can plan accordingly. Evaluation. How are you going to be graded? Where are your scores going to come from? Course particulars, technology and assignments. Now this is going to vary depending on what course you're enrolled in. One thing that you'll see in chemistry at Emory is we do use a lot of technology. So there is an online learning assessment tool called ALEX that we require all students to use throughout the first semester, and that's going to contribute to about 10% of your overall grade. That tool is used to make sure you're staying on top of the work and where you're at, that you are where you need to be with respect to studying, but it's also a tool for you to let you know if you're really struggling that you might want to get additional help in certain areas, okay? How to be successful in Chemistry 142, I'm going to talk to you about that, and the resources that are available to help every student at Emory. So let me start with my role. My role is to relate and describe relevant chemical concepts and ideas to you in a concise manner. And I also consider my role to be precise and diligent in teaching. And that means making clear what I expect in terms of assignments and what I expect you to know for exams, okay? And the reason that I'm going to do that is I need you to leave Chemistry 142 with the best foundation that you can possibly have. So when I asked how many were going to be chemistry majors, I only saw maybe one hand go up. But when I asked how many people were planning on majoring in a major that required 142, all the hands went up. And this is something I want you to know, that you'll see these concepts, and even more than just the chemical concepts, one of the reasons that chemistry 141 and 142 are so foundational is it's not just the chemical concepts, but we're going to teach you problem solving. So what you really learn in chemistry is how to solve problems, right? When given a certain amount of information, how can I take that information and use it to get to some answer? So what I expect of all of my students that take a course with me, that you have to be actively engaged in the learning process. This means coming to class, staying on top of the homework, continuing to work on your ALEX, your electronic learning assignments, backup book problems, to keep up with assignments and readings, and to understand concepts rather than memorization. This is a huge one that I want to stress. So I told you all that I don't tend to teach the first semester of chemistry, right? I teach the second semester of chemistry. So something really interesting happens during the second semester of chemistry. And that is there will be a group of students who've done well, maybe in 141, the first semester, maybe they got a B, maybe they got an A-. And after the first exam in 142, they realize they're crashing and burning. And the reason is because students will have used the study skills that they used throughout high school to try to succeed in the second semester course. And what I want to stress is that you cannot memorize. You cannot look at the solution manual and memorize, all the different ways to solve problems, because I will figure out a way, and I don't do this to be cruel. No one who teaches chemistry at Emory does this to be cruel, but we'll figure out a way of asking the question in some way that you haven't seen before. Does that make sense? So the students who memorize really tend to hit a wall that second semester. That's where we see big decreases in grades, okay? Because first semester, you've had a full year of chemistry. Many of you have had a full year of chemistry before. You've seen a lot of this. You've studied. It's not brand new to you. But when you get to that second semester, we're moving at such a pace that just memorization really won't work. You really have to work to understand the material. And what that means sometimes is actually reevaluating how you study and how you prepare for exams. So understand concepts rather than using memorization. And lastly, what I expect all students to do is use the resources available to you. And I want to talk a little bit more about that. Let me just picture it really quickly. And pull this up. pull up a sample syllabus for you. So we can review it. And as I said, Drew will make sure that you get them, that you get a copy of this.
The 142 that you sent me is already, guys, it's available on the residential portal.
Okay.
Right at the bottom. It's already there.
Thank you, Drew.
Sure.
Thanks. So I just wanted to take you through what the syllabus would actually look like. So this was the course I taught this past spring. So it's going to have my name, my contact info, the head TA's name, her contact information. Really important, our office hours. Mine tend to be Monday, Friday in the afternoons. Hers were Tuesday and Friday. Other by appointment only. And then I told you we were going to talk, it would technically tell you what we're going to cover, right, in the course of a semester. And what I want to stress is that, so in the spring semester, basically, we covered chapters 11, 12, 13, 14, 15, 16, 17, 18, and 19. We got through 19. So basically what that means, that's a lot of chapters in a very short period of time. And if you notice when the course was scheduled, we were in lecture for an hour and 15 minutes twice a week, and we worked through a chapter about every 2.5 lectures. So we're going through a chapter basically every 2.5 lectures. So the reason I want to stress that is that really means you have to be on top of the homework, because you're going to be 3 days in to the first semester, and I will finish the first chapter. And I will have assigned you about 30 problems from the back of the book. You'll have, and in addition, that Alex work, things like that. So it's really important that you stay on top of the information early. Because we have so much information to cover, we work at a pretty good clip. Does anyone have any questions about that? Does that seem pretty fast, or does that seem normal? Seems pretty fast, right? So I hear this from students a lot.
Do we die?
Yeah. I know, and I'm telling you this because I know that it seems fast, and it was, I also want you to know that I'm not trying to cover 5 additional chapters. This is what we agree on as a faculty, that you need to know, you need to have this information before you progress on. And the only way we can get through it in the course of a semester is to move it at a good clip. So I think it's important for you to see that and to not be shocked by it. So the first day of class, you're going to actually cover material. You're going to move through it. So evaluation. In my course, the final exams were 30%. You'll take 3 regular or midterm exams throughout the course of the semester. I only grade 2 of those. Everybody, all the faculty have different ways of doing their, working through their grading. I basically only count, I only count your top 2 of those 3 interms. So I let you drop your lowest score. Does that make sense? One of the reasons I have that policy is because students get sick, things happen, not everyone can make every exam. So I don't give makeup exams during the regular semester. So if you get really sick, can't make one of the regularly scheduled exams, that's your dropped exam. Your grade is based on the other 2. Does that make sense? Okay, so 2 in-class exams, 2 out of 3, your top 2. Alex, there are 2 different modes to Alex. You're using Alex now, right?
They should be, yes.
Oh.
Well, for chemistry now, and for us, for our calc, they'll start it tonight.
Oh, okay. So you'll see, it depends on how it's set up for the math, but there are 2 different modes, and in chemistry we base 5% of your grade on the learning mode and 5% on the assessment, which is basically these mini quizzes to see how well you're retaining the information. And then the laboratory portion of the class is worth an additional 20%. So that's where the foundation of your grade is. So you notice the one thing that you don't see in here is the homework, right? I talked to you, I said I'm going to assign you back at book problems, things like that. I will never, I was going to say, I will never know if you don't do your homework. I will know if you don't do your homework because it's incredibly transparent on the exams. So one of the things I like to do is I like to think about, as a faculty member, I like to think about what are the qualities of students who do well in the course. Right? And one of the really powerful things about Alex is because it's all computerized and you have an individual login ID and things like that, I can look at the end of the semester after I assign final grades, I can look at things like when do students start their Alex assignments? You know, how much of them do they complete? What's their final grade? And I will tell you there's a correlation between starting things early and performance in the class. Students who wait until 24 hours before, the ALEX assignment is due to begin it, tend not to do really well in the course. And I'm not trying to be mean and I'm not trying to scare you, but it's reality. Like if you wait, you know, I will have given you the ALEX assignment. You'll have 10 to 12 days to complete it. If you wait until day 11 of that 12 days, it just does not go very well. You want to be doing a little bit each day.
So when our teacher gives us our syllabus for a class, the textbook we need for the class, is that going to be under course content?
Yeah. Yeah, it can be under course content. Some faculty will have a separate, just textbook information. Some will have required text and then optional text. You'll see that as you go, as you get into the upper level courses, often we'll just have one required text, but then 2 or 3 that are optional. With those optional texts, and I do this with general chemistry, I tell the students, we always try to put a few books on reserve in the library. So if you want additional practice problems and things like that, you can go and check them out, but only for an hour at a time.
Okay.
Does that make sense?
Yes.
Yeah, that's a good question.
Would you recommend to wait to buy the books until we get in the actual course, or would you want us to have them beforehand?
I would recommend, my experience would say get them ahead of time if you can. If it's at all possible for you to get the texts ahead of time, do it. It doesn't happen often, but sometimes there is a run on textbooks. So if students don't have them by the first day of class, there's a week backlog, and then you're sharing with your roommate or using the one at the library. It's uncomfortable. Go ahead, do you want to add?
I would just say if you guys could stop at the bookstore, say while you're in GLUE. There will be several texts that are probably already in the bookstore now. So you guys, that's something, like I said, you guys can start taking care of now before the craziness of the fall.
Before the craziness of the fall. The other thing is, if you're able to, if you can work it out to get them early, there'll be more used copies available, and they're a lot less expensive.
Yes.
You know, you can get the used copies for maybe $60 to $70, and the new ones are really expensive. So that's another advantage. You can save a little bit of money.
Regarding the laboratory aspect of the class, is that 20% grade purely lab report, or is there additional?
So that's a great question. Currently the way that's set up is laboratory grade is calculated based on your lab reports, and 5% of, well, 5% of the 20, I guess about 25%, 20 to 25% of the laboratory component are lab quizzes. So they will give you quizzes, but it's mainly pertaining to lab information. The experiments you're doing, the calculations you're doing, things like that. Does that make sense?
Yes.
In the laboratory section, you'll have a small section, 20 to 25 students, and a TA that will be walking you through that. Okay, course particulars, exams. Okay, this tells you what I've already told you. No makeup exams are ever issued. Your lowest in-class score is dropped. That's the way that works. Calculators. Okay, calculators, I'm going to tell you this day one. Don't go to class without your calculator. So if you're going to Chemistry 141 or 142, take your calculator on day one. Expect to use it every day. Errors in grading. Because I told you that these courses are a little bit larger maybe than what you're used to, errors do happen in grading. And what's most important to you is if you get an exam back, even if you think, hey, I did okay, right? I got an 80, I got an 82, I'm above the class average, I'm okay. Look at that exam really carefully. The exam key will be posted. The reason I'm telling you this is because I'm not perfect, and when I grade with my team of graders, we're not perfect. We make mistakes. You want to make sure that you get credit for it as soon as possible. No faculty member is going to tell you they won't look at an error in grading. Some of the most common errors we make are addition. You know, just adding the points at the bottom of the page. My exams are traditionally between 7 and 10 pages long. We make errors just adding and transferring those scores to the front because we have so many to get through. But it's really important that as soon as you get a graded exam back, you look at it. Look for exam errors, look for adding errors. The honor code. This is really important. Every student enrolled in Emory College assumes the honor pledge. On the front of many exams that you take at Emory, we're actually going to ask you to sign that, the honor pledge. By signing your name, you agree to adhere to the honor pledge. Violations or academic misconduct, they're not accepted anywhere within the college. And basically, I include the full details of the honor code on my syllabus, but most students will be taken through that fully at orientation and what the outcomes are, things like that. In-class behavior, please be respectful of your students. I do not allow the use of cell phones, iPods, or laptops in class, so let me be a little bit revisionist there. I ask that if you're using a laptop with the screen that you sit on the edges of the classroom, just because everyone behind you in the tiered lecture hall will be trying to see what you write. It's just human nature. That's what they like to do. So technology and assignments. So I talked to you a little bit about Alex. You'll be walked through this, how to do it. You'll get an Alex code. Blackboard. Blackboard is our online community for a course. It's really important that you look at Blackboard regularly for all of your courses. This is where all of your homework is going to be posted. This is where I'm going to put copies of the syllabus. This is where I'm going to put practice exams. Any PowerPoints that I use in class are going to be posted here. So this is going to be where the class basically lives. The other two things I want you to know about the Blackboard's sites associated with your classes is typically there'll be only 1 or 2 people that can add content to the whole site. You know, so myself and my TA, we can populate the whole site and put things up and answer questions. But there is always a section called discussion for the class. Everybody can contribute to that. The faculty and the TAs, they do monitor that. If you're working through the homework and there's one you're really stuck on and the answer's not in the back of the book, or maybe there's only an answer and no solution, students will often start using that discussion section to ask questions like, did anyone figure out how to do problem 122? How did you do it? How did you start it? Did you get the right answer? And so we'll monitor that as those discussions take place so we can jump in and kind of add our 2 cents as you're working through homework, things like that. Okay, so how to succeed in 142, this is really what I wanted to talk about. Your performance in the course depends on you. You must dedicate time and energy to this course if you're going to succeed. I tell everyone, for every hour, for every in-class lecture we have, you should be doing 1 to 2 hours of homework afterwards, right? Because I told you the clip we're going to move through. And I'm going to walk you through a sample chapter so you can see. So we'll start with chapter 11. But basically, we're going to cover 4 to 5 sections of that chapter in one lecture. There'll be a lot of homework associated with that. There'll be at least 20 problems from the back of the book, and there'll be Alex associated with that. So you can start as soon as the first lecture is over. Reading. Read the applicable sections of each chapter to make sure that you conceptually understand the material. One thing that I hear from students a lot, I'm just going to be honest with you, is students will tell me, they'll say, I sit in your lectures, everything makes sense, I take notes, and I go home to start the homework, and I have no idea how to begin. Right? Students will tell me this. Even though I do sample problems and things in class, I work through sample problems, but they'll say, I get to the first question, I don't know how to begin. This is where I think it's important to refer back to the textbook, because one of the great things about textbooks is the textbooks for each section, they're going to have 1 or 2 example problems. You can go back and they walk you through it step by step. And I always tell students, especially if I get an email, and students will email me maybe at 6 o'clock on a Friday afternoon, Friday evening, they're like, I'm just sitting down to start chapter 11 and I can't even start the first problem. I'll say, go back to this section, look at the sample problem, work through it, let me know if that helps. Then usually 30 minutes later, I'll get an email that said, yes, I get it now, I remember. And it's typically something like they weren't making a conversion that they needed to, or something like that. But look through those sample problems. The textbook is a tool that you can use. So I always tell students chemistry is like a sport. You don't get really good unless you practice. Practice comes from doing the problems. Time. You have to be able to commit a significant amount of time outside of the classroom to succeed in these courses. You need to have time for reading, you need to have time for doing practice problems, and to really master the material, right? And remember, a big part of this is 20% of your grade is going to come from lab. That chews up 3 hours of your week just in lab. And we haven't even talked about the time you're going to be spending preparing for that, right? So that's 5 hours that you're going to notch off just on lab. 20%. So think about the other 80% of the course where you're going to have to dedicate to do well. Okay, and this is not meant to scare anybody, but this is very real. And I tell everybody this, and I'm one of the faculty, Drew knows this, I send out emails at the beginning of the semester. Because I can see everyone enrolled in my course, and I know how people performed in 141. And basically what I tell people is consider your past performance. If you got a C- or lower, because remember, C- and Ds are technically considered passing, I tell people that if you get basically a C in 141, you should rethink your study habits and prepare to dedicate a significant amount of time to 142. Students find 142 harder than 142. It's more math intensive, there's more problem solving, we cover a little bit more new material. And I tell students, this is Drew knows I send out emails. If you received a grade of C- or lower, I tell students, do not take this course. If you got a C- or lower in 141, you will not do well in this course. I mean, I have 8 years data that says, do not take this course. So I send out these emails and I say, please come see me, let's talk about it. I really want you to reconsider taking the course. Only about 50% of the students listen to me, but the reason that I'm telling you this is because one of the things that really impacts students is that they think, okay, maybe I had an off semester, I'm going to do better this semester, I'm going to turn everything around. You're far better served going back and mastering that beginning material. Go ahead.
Sorry, this is kind of off topic, but if you took, like for example, I took my chem my sophomore year, but I took calc my senior year, would you recommend people who kind of have a knowledge of chemistry and are okay at math to take a math class before entering the 2 semesters of chem? Or do you suggest just try out chem and then learn it?
I kind of feel like if you have a good
algebra
foundation, you're fine. But you have to be pretty solid in algebra. Would you add?
The thing I would keep in mind is chemistry does not usually require calculus. You guys aren't using calculus. You're using algebra. Now, depending on your foundation of algebra, that will tell you, are you ready for 141? Then look diligently at how you did at 141 to decide if you're moving on to 142, or if you need to come and have a conversation with me, and we would have had several already, if you're not feeling really comfortable with 141, and we would have decided what is the best thing for you to do. Should you focus on your math? Where are the skills at that we need to help work on? Yeah.
And one thing that we do for all, and Drew, is chemistry, are we still the only ones that do it in an entrance exam?
Yes, so far.
So far, and these guys have not taken that.
They should be taking the GCAT now.
Oh, okay, you did, okay. So the chemistry department, chemistry at Emory, we administer something called the GCAT, which is the general chemistry kind of admissions test, and it's based on ALEX, and what it's going to do is it's going to tell you where you're at and what course you should sign up for. And people that have had really strong, solid chemistry backgrounds, sometimes what they'll do is they'll test really well on the GCAT, and they'll say, you don't need to take 141 and 142, you can go straight into organic. Well, and it's interesting because what happens is a lot of students look at that and they're like, no, thank you. And so even though the test recommends that you go straight into organic, students will still take 141 and 142, and that's fine. It's about doing what you're comfortable with.
Okay, so let's say you like super tank the GCAT, like you're not, I mean, you're just going to go into the first entrance course, right? It's not going to hurt you.
It doesn't hurt you at all. It doesn't hurt you at all. But what it'll do is it'll basically say, so if you super tank at the GCAT, it's going to say, okay, go into 141, and it's going to say, make sure that you're prepared. Like, you'll be advised, basically, you can do this, you can take this course, but don't take 3 other really time-consuming courses at the same time, because you're going to need to spend time on this.
If you have all intentions to take 141 and 142, even if the MCAT says you don't even know to go to college, like it's gonna, like regardless of what it says, like you have full intentions to take 141 and 142, do you have to take it because you plan to take 141 anyway?
Could you ask that question one more time?
Do you have to take the GCAT if you?
Yes.
Even if you plan on going to 141 regardless of what?
Yes, you do, and here's why. It's not to punish you, but it's really about gathering information. We want to know, how we're serving our students and where are people coming in, and where are deficiencies. So we ask everyone to take it. And even if you're like, I don't care, I'm taking 141 and 142, I'm just going to go through it. Just take it as a survey. Do your best. It'll prepare you. It's practice. It's going to expose you to some things maybe you haven't seen or thought about before. But don't let a performance on the GCAT make you feel inadequate or anything in any way, because it really is a placement exam to say, where are you?
Once you take the GCAT and you fill up your ALEC pie, that is 3% of your 141 grade, right? That's what you submit to your teacher on the first day?
Yes,
Just making sure.
that's right. So even if you're going to take, that's a good point, 141, what we do to reward you for doing it, filling up that pie on Alex. If you haven't started it yet, you don't know what I'm talking about.
It's pie.
It's
so yummy.
3% of that will be factored into your first semester score in 141.
So if you do really bad on the GCAT, like if I got like probably an 8%, and that's like an 8% grade in my chemistry class, that's gonna bring down my chemistry grade.
No, you're gonna get 3%. Like it doesn't punish them for not doing well.
Yeah.
Just for completing the GCAT, you'll get that 3%.
It's completion, not content.
Yeah.
You did the test, so they give you 3%.
So you're getting
it's not
rewarded.
8%.
No. You're getting rewarded.
Regardless.
You're going to be rewarded
It's
just
the
for
filling of the
completing.
pie, which is the 3%.
Yeah.
The test is the easy part. Well, it's the filling of the pie, which is the big sign. Yeah.
Yeah. So you're going to get credit just for doing that. Does that make sense? So it's really just meant to kind of tell you where you're at in the continuum. And what I see more often than not is I see students getting recommended for organic chemistry because maybe they had a really good high school background, but you don't have to do that. You can opt to take 141 and 142 if you're comfortable. So I wanted to talk a little bit because I said that one of the things you're going to want to make sure that you do is use resources that are there to help you. If you find yourself struggling in any courses, not just chemistry, any courses, Emory has this amazing program called ePass tutoring. Have you talked to these? Do they know?
ePass will be coming, Julie will be coming to talk to them, I think, next week.
Okay, perfect. Well,
Yes.
this is just a preview. ePass is an amazing resource. If you're having problems or struggling in specific content area or courses, you can go online to something called ePass Emory, and you can sign up to meet with a peer tutor that's done very well in those courses that will sit down and work with you. I think currently it's like up to 2 hours a week they can sign up for. 2 hours a week in any given subject, and that's completely free. You just go online, fill this out, you'll set up a time, a place to meet, and they'll help you. So that's really useful. We do something unique in chemistry that I really, really like, and that's called Chem Mentors. And Chem Mentors is unique because it's a weekly workshop, and it's led by a senior chemistry undergraduate student. So not a grad student, it's going to be one of your peers who's maybe a year or two ahead of you. And what it is it's a worksheet that basically the faculty, we all come up with together. So it doesn't matter who you get for a course, whose class you're in, we all come up with the same Chem Mentors worksheet. The only way you can get the worksheet, here's the thing, you have to go to the workshop. You have to go to one of the workshops. Don't email your faculty member and say, hey, can you send me a copy of that? Because they won't. Most of us don't even keep copies of the worksheets. You have to go to one of the sessions to get it. We have a ton of sessions every week. Morning, noon, afternoon, weekends, the students run them, right? There's only one workshop per week, but there's always a time that you can go. You just have to find one time to go. You sit, it's kind of like a problem-solving type environment. You work in small groups on the problems, and then that student, peer mentor, takes you through the solutions. And they tend to be small groups, which is nice. It's 10 to 20 students typically show up. Really great exposure to material that's likely to be on the exam. It's good practice for the exams. Your fellow students, I always say, form study groups, tackle difficult material together. Peer learning works. And lastly, don't forget about whoever your faculty member is and the head TA. Come by office hours, meet with people, talk to us. Okay. Are there any questions on the syllabus? So what I'd like to do with kind of the time remaining is go ahead and just continue with, basically on the first day of class in the spring, I spend about 15 minutes going over the syllabus and student expectations, and then we launch right into chapter 11. And because the courses tend to be a little bit bigger, I do work on the board, right? I'll do a lot of problem solving things on the board. but all the content material will be backed up with PowerPoints, and that'll be all available to you online. Okay? So chapter 11, traditionally what I do is I tell students how many sections. So chapter 11, this is a relatively short chapter. There are only 8 sections, so we would be done with this in 2 lectures. We would get through all this material. So why don't we go ahead and launch into chapter 11, the properties of solution, by talking a little bit about solution composition. So mixtures. Mixtures have 2 defining characteristics. Its composition is variable, and it retains the properties of some of its components. Okay, that's a mixture. Composition is variable. A solution, in contrast, is a homogeneous mixture. Components of a mixture are uniformly intermingled. There are no boundaries separating its components. It's all one phase. So think of something like concrete. So there's a slab of concrete and you break concrete, right? You look at it from the side, what do you see? You see boundaries, right? You see the pebbles embedded. There are actual boundaries. So that's concrete would be an example of a mixture. Think of a solution. Think of a solution where you can't see defining boundaries. Can someone give me an example of something that would be a solution?
Water.
Water. Well, water's a pure solvent, right? So if there's nothing mixed in it, it's just pure. Salt water. Salt water. Yeah, that's a good example of a solution. But we'll talk about pure solvents in a minute, so that's a good heads up. The other thing I want to remind you is that solutions can be gases, liquids, or solids. Remember, the atmosphere around us, the air that we breathe, right, is technically a solution. It's not one pure component, but rather a mixture of multiple components. So let's go ahead and look at some examples. Examples of various types of solutions. We have air and natural gas, a state of solution gas, state of solute is gas, and the state of the solvent, the thing that does the dissolving, constitutes the bulk of the solution, is also a gas. You can have things like vodka. Not that anyone in here has probably ever sampled it before, but vodka is actually a solution of water and ethanol. Those are the 2 major components. Brass, door handles, we see brass, ornamental brass everywhere. Brass is a solid solution. The state of the solution is solid, the state of the solute is solid, and the state of the solvent is solid. Brass is a mixture of copper and zinc. So the point of this is just to show you there are tons of different ways you can create solutions with a lot of different components. And there you see the seawater, you mentioned salt water. Seawater or sugar solution, there we're going to have the solvent, the water, right, being a liquid, but what we dissolve in it being a solid, but what we result with is a solution that's liquid. So because solutions have variable compositions, the amounts of substance in a solution must be specified. Okay, so we can say something's a solution. I can say, I'm going to provide you with a saltwater solution. Do you want to drink it? And you would say, well, how much salt is in there, right? You kind of want to know how much of the solute is in the solvent. That'll help you decide certain, if you're going to drink it or not. So because of that, we basically have a lot of different mathematical ways of expressing the compositions of solutions. And what I have here are just 4 different ways that we could express the composition of a solution. We have molarity. This is very common in chemistry. This is probably our most common form of expressing solution composition. And molarity is represented by this capital italicized M, and that is basically moles of solute. Remember, that's the thing you're dissolving into the solvent. That's going to be the thing that is dissolving the solute to make your solution. We can have mass or weight percent, which is basically just now, instead of using moles per liter, we're going to use the mass of the solute and divided by the mass of the solution. And then, of course, because it's a percent, we're going to multiply that by 100. Mole fraction. This is represented by chi sub A, where A is the component of the solution we're interested in. So sometimes we'll have solutions that contain maybe 2 or 3 solutes and 1 solvent. So maybe we're going to make a solution, because we like dissolving things in water, we're going to make a solution basically of sugar and salt and water. And we would want to specify, are we interested in the mole fraction of salt? So I might write chi sub NaCl. Are we interested in the mole fraction of sugar? What are we interested in? So you have to specify the component you're interested in. Once you do that, you then take the moles of that substance you're interested in, divided by the total moles in the solution. And this would include the moles of all the other components. And finally, down here at the bottom, I'm sorry if you can't see it in the back, is molality, little m. Molality, chemists, we don't use it quite as much, but the biologists use molality a lot. And that's moles of solute divided by kilograms of solvent. Go ahead.
Do we always have to learn a molecular formula, or can we read it?
No, you can, just as long as you basically know what you're doing. So sometimes, a little later in this semester, we're going to be doing things like Raoult's laws, and we're going to be looking at composition of gases, things like that. We'll be talking about pentane and octane and hexane, and often what I'll do is I'll just do, if we're talking about hexane, I'll just do chi-hex, you know, stuff. So I know that I'm talking about hexane. It's really a tool so that you can keep track of the components of your solution. So if you have 8 grams of H3PO4, does anyone know what this compound is? Does anyone remember from naming? We did this last semester. This is what I was telling class. We did naming last semester. Trihydrogen phosphate. It's also found in Coke. What's its common name? Does anyone? Yeah, it's an acid. Phosphoric acid. Phosphoric acid. You'll do a lab later this semester, well, in 142. You'll actually do a lab where you isolate the phosphoric acid, the amount of phosphoric acid in Coke. So what we would traditionally do here, and I'm showing you this is because I would pop a question up on the board and I would expect you to work it in small groups or individually. You'd have about 2 minutes, then we'd go over the solution, okay, together in class. So the molecular weight of phosphoric acid is, because we don't have a periodic table in here, I'm sorry, let me just give that to you, is 97.99 grams per mole. That's the molecular weight. And why doesn't someone go ahead and do this for us? May I?
Yes.
Sorry, I'll put it up there. 97. Sorry. Who's got the molarity of this solution? Someone tell me how we'd start this, because we're just getting warmed up. Go ahead.
Well, I would convert the grams per mole to just moles.
So how would you do that? Walk me through it.
Well, I would divide it by the 8 grams.
So I'm starting with 8 grams of
Yeah,
H3.
and divide 97.9 grams.
And what's that going to give us? Moles. Good. Will someone check my math?
That's right.
Is that right? So everyone got that for moles? So going through this, we started with 8 grams of H3PO4. We're dividing by the molecular weight in grams. So normally we think of molecular weight as grams over mole, right? But to use it in this problem, we have to invert it so we can cancel the grams of H3PO4 and end with moles. Does that make sense to everyone? Everyone's okay with that? Good. So now we have this moles. I look up here and I see that moles are moles of solute versus liters of solution. So what do I do next? Right, so I've been given this in milliliters. I need to convert it to liters. So 100 milliliters is how many liters? 0.1. Good. So now we're just going to take our... So that's our liters of solution. What do I end up? anyone get it? Does anyone have, you have a calculator?
816.
Pardon?
0.816.
0.816? Got that? Does that make sense to everyone? If you didn't have a calculator? Is everyone okay with that? Let's try this. If you have a 10 molar sugar solution, what volume of this solution do you need to basically get 2 moles of sugar out? How much would you have to pour and dehydrate to isolate 2 moles of sugar? So you have 2 moles of sugar. And you want, I'm sorry, you want.
And you use about 10.
And everyone sets things up a little bit differently, but this is just the way I do it. So you're telling me 2 moles of sugar divided by this plot. We're going to cancel moles of sugar. Good. And we get how much? 0.2 liters? Good. So what you can see is really, when we're dealing with these concentrations and how we express concentrations, it's just really becoming comfortable with manipulating these different ways of expressing the composition of solution. Does that make sense to everyone? Okay. So it's not, and we can do, I have, typically what I would do in a class is I would go through tons of these. I think that I have, you know, sitting in class, we would basically go through a bunch of these. And I'll give these to Drew so you can put them up.
Thank you.
And you can practice them. But we would do examples of molality, but then we would move on. So what we would have done then is we would have completed that first section, would go on to the second section, would go on, we'd probably try to get through 4 different sections in the course of that first lecture, 3 or 4. We would have spent some time going over the syllabus. But does anyone have questions? What I want to make sure that I allow time for is for you to ask questions about succeeding in class, what to expect, what other information can I give you? This is the pace at which we would go in the course. And people come in ready to work because, you know, we do have a lot of material to cover, so. Go ahead, someone have a question. Sorry, yes.
Okay, earlier you said that you gave us like at least 20 problems to do after class and not to wait until the last minute to do it. Is it also a bad idea to try to get it all done that first day?
No, it's not a bad idea at all. If you can do it and then go into class having completed all the homework, you'll be way ahead of the game.
But then like since you're not doing a little bit every day, you don't think that maybe you forget everything because you did it all in the first day?
No, well, because I think that we will, so let's say you complete it all before, let's say, you know, we go in day 1, you complete all of chapter 11. You know, when you go to the next lecture for chapter 11, you're going to have worked through all the sample problems and stuff, right? So you will be able, when I put the problem up there, you know, like let's do this in class, you'll know how to do it. You'll already be primed and ready to go. So I think if you can do it ahead of time, that's great. Like I would encourage you to do that if you can, if you're able to. Sometimes it's difficult because even, you know, students who do really well and have had great high school prep will still tell me, oh, it took me 3 hours. You know, like it took me 3 hours to do chapter 11 and I had all of that before. Just because of the number of problems and things like remembering how to do conversion. So if you haven't had chemistry since your sophomore year, someone said, I haven't had it since my sophomore year, you forget, right? Like maybe you haven't had to do unit conversions. And the person, pardon?
What is chemistry?
See, exactly. The other thing that I want to stress to you is that I think one thing that's really challenging is that you're going to walk into a course, right? And there are going to be people maybe that you're living with in your dorm, or people you're sitting next to in class, right? And you're going to walk in, and maybe you've had really great chemistry training, right? So you know how to do all of this. No problem. You've got all the unit conversions. This is easy. But if you're the person sitting there who hasn't had it since their sophomore year, what happens is on that first day of class, panic sets in, and I see it. And I always try to tell students, it's okay, I know you haven't had this for 3 years, like it's going to come back to you. But panic sets in because if you're that person who maybe hasn't had it in 3 years or has never had the course, you're like, how do they know this? And why is she going so fast? And why does everyone seem to know what's going on except me? I have to tell you that that feeling, I want you to know, you're not alone. Even though you'll sit sometimes in class and you'll be like, how do they know this? Or like, I don't think I was ever taught this. You are not alone. Other people in that class are going through the exact same thing that you are. The difference is you have to be, you can't allow that feeling like I have no idea what. I've had a student come to me before. It's a true story. I think Drew has heard this story before. I've had a student come to me the first day after 141 and say, I'm a senior at Emory, right? So they're a senior at Emory, arts major. So they didn't take any of their science. They got AP credit for 141. So they waited until their second semester, senior year, to take their second science course. I'm not making this up. This is a true story. She was an arts major. It was, you know, she put it off. She didn't really like it. She had enough chemistry to get credit for 141, you know, on the AP exam. Hadn't done that since her sophomore year. So now you're looking at her junior year in high school, senior year, freshman, sophomore, junior. She hadn't seen chemistry for 5 years. She came to my class, first day of class, she said, Dr. MacBeth, it's like you're talking a different language, you know? She's like, I have no idea. She sat in the middle of the lecture hall, and I just saw fear and dread. But what she did is she came and she told me right away. She said, I have to have this course to graduate. She was doing really well in her major. She was an arts, I mean, that was her passion. She was doing really well. She needed this course to graduate second semester. The difference is, she identified it. She was a little more mature. Most of the students who come in are, you know, freshmen or maybe sophomore taking the class. But what she did is she identified it right away and said, this can be maybe a little bit of a problem. What can I do? And I said, well, I'm going to get you hooked up with an ePass tutor right away. Start this. And she got through the course. Now, I'm not giving any names so I can talk about it. She finished the class with a B-, right? She had a great GPA. She knows more about arts and literature than I could ever hope to, right? Like, she is science engineering background. She's brilliant. That B- doesn't mean she worked for that. She told me she was prouder of that grade than anything else she'd done. Because she's like, that was blood, sweat, and tears. But the difference is that she identified it right away. And what I wanted to just let you know is, it's really easy, especially during your first year, to feel like everybody else knows something that I don't. Like, everybody gets this, I don't. Trust me, 80% of the people sitting around you, they don't have it figured out yet. They're just acting. Right?
Exactly right.
We've talked about that.
We talked about this already. They just came in on Wednesday, we've already had that discussion.
Oh.
But we need them to hear that discussion over and over. It is exactly true.
Like, sometimes I just want to get, you know, I tell students, come to the office hours, get to know me, let me. You know, and sometimes students will come and they'll be like, everybody else knows this, or they have this figured out. And I'm, no, they don't. I'm seeing what they're doing. I can list 8 kids out of 100, sorry, I call you kids. I'm like, I can list 8 students out of the 120 that really have this stuff.
Mm-hmm.
You know, like, and I know who knows what's going on and who doesn't, and who maybe has had the best prep and who hasn't. And those 8 students that really know what's going on, they're not who you think. You know, they're the ones that are quiet in the back, completely unassuming. The ones that are like, rah, rah, rah. They're probably going to pull a C on that first exam if they're lucky. I'm serious. It's just because, I don't know how else to express it. You know better than I do, but students feel sometimes that everyone else is better prepared, or they know something that somehow, you know, they haven't figured something out that everyone else knows, and it's just people I don't know.
Yeah.
No one knows. I'm telling you, 90% of the people in that room are just sitting there like, oh my gosh, she just floored me. I mean, I followed students, I follow students out when I teach in like hall. I really don't have much of an option. I have to follow them out of the lecture hall, and I hear students like, did she really just do that? Did we just cover 5 sessions? Are there 50 homework problems? And I'm like, yeah, and we're going to finish chapter 11 on Thursday, and I'm going to post another 50 for chapter 12. So you know, again, I'm not telling you this to scare you. I'm just saying take some solace in the fact that everyone's...
You're not alone.
You're not alone.
No one is alone.
I'm not telling you this to scare you. I don't know about you. It's like you're like, I'm not telling you this to scare you, and I'm like, I'm here like, you know, like carrying my life.
Is it working? Is it working? Well, I just want you to know that you're not alone, and we're not. So now you're all terrified.
No, I mean, in the end, all you've managed to do is let us know that there are other people crying just as hard as we are. That's about all you've let us know.
I just want you to know that no one else has it figured out. I mean, like, it's just...
They don't.
Go ahead, I'm sorry. I want you to do well. That's why I come and do this every year.
Exactly.
The formulas we recently covered, do you favor a particular one, and will you tell your students that on the exam?
So I started doing something about 5 years ago that I think now everybody in Gen Chem does, but I was the first one. For the formulas and stuff, I just give them to you. They're included on the exam. I give you a full sheet. Because, hold on.
But, okay, yeah, there's a flip side to that though, guys, and she's going to tell you. Yeah, there's...
I want you to know what it looks like, so just give me one. So here is the sheet that I would give everybody for the final. Sorry.
It's in English.
Wait, it's kind of rude.
Sorry. So the problem is you have to know how to use all of these, and we will cover all of these. You have to know how to use them, and you have to know how to manipulate them. So my personal philosophy is I don't want anybody, you know how I told you I don't want anyone in my class memorizing anything? I feel that way about formulas and stuff as well. I figure, you know, I'll give you the formulas, but you have to know how to manipulate and use them. So here's like the stuff that we will have covered in chapter 11. This is the stuff we'll cover in chapter 12. You know, and then we'll go through all the kinetics, right? 0 first, second order, and then the half-life equations. But I'm telling you, for second order, you know, this is the equation for half-life. The problem isn't how, like, oh, this is easy, right? You have to know when to use this. I mean, where it gets, it's not that we're going to try to trick you. I don't want to make it seem that way. The problem is you're not going to, I'm not going to tell you, for a this second order reaction, I want you to solve for this half-life. I'm not going to tell you that. I'm going to say the rate for some reaction is this and expect you to know from the units that it's second order, right? And during that exam on kinetics, people come up to me and they're like, you haven't told me what it is. And I'm like, it's in the problem. Because if you know your units, if you can go through and solve, you can figure out what the units for second order is, and then you have to imply that. So I don't want you memorizing this, and now I think almost everybody gives the equations because it's just not worth your time to memorize. So you would get a sheet like this. This was for the final. This was everything that we did, and then electrochemistry and things like that. So the challenge is in how to use it. But you would get all that, and you'd get a periodic table one. Do you want to see like a final so you can see what it looks like?
Why would I want to see it? Yeah, it'll just look like, it'll look like a scrambled alphabet with letters in it.
They'll start picking it up.
Is it too late to drop out?
Yes.
Cross with a unicorn? Okay, so for my final exam, so the final exam you'll have 3.5 hours. That's or about three hours to take it.
But you have it all.
And then
That's standard.
No, I'm
4 hours in my
We
class.
might.
so there's often a lot of multiple choice. So trust me, we cover this during the course of the semester. One thing that I do, because I think it helps the learning process, is I try to order my exams in the order we covered materials. So this has something to do with solutions, so it's the very beginning of the semester.
Okay, guys, that is super nice. I just want you to know that right now. Neither one of us do that, and don't expect that. That is incredibly nice.
No, I do, because they're panicked
They
anyway,
are.
so I want them to feel I want them to start off right. So,
I mean,
when
sociology.
potassium hydroxide is dissolved in a beaker of water at room temperature, the flask becomes warm. Which statement is true about this solution process? Number one, potassium hydroxide isn't very soluble in water. This solution process is endothermic. Delta H solution is less than 0. This was I think this was a draft. I already listed that one. Or delta H solution is greater than 0.
No idea what any of those mean.
That's why you take the class.
What do we got?
I'm just asking a question.
Oh, okay. Go ahead.
How much student interaction is there, like in a gym or in your class? Like, how much would there be back and forth?
In my class,
Yes.
like when I'm teaching, oh, a lot, because in my class a lot, because what I do is when I get my grade at the beginning of the semester I get my roster, I can print it out with everyone's picture on it. So by the end of the third lecture I will have called on everyone in my class once. And during that first part of the class I get to know students, so I'm like, what's your name, where are you from, tell me something interesting or funny, and then I try to remember. So there's a lot. I call on people. We do a lot of small group work, things like that. I think this was my draft. I don't know if this is fine. But so, and again, you can see as we work through, we're talking about solubility and solution, so I'm going to go more into that, and then we're going to start kinetics, which is chapter 13. So this is multiple choice, but it's not all multiple choice. Then there'll be some short answer stuff, right? Student wishes to create a voltaic cell from materials she has in her laboratory. She finds manganese, manganese chloride, nickel 0, nickel chloride, KCl, a voltmeter, and some electrolyte. Help her out by diagramming the cell below. And so basically, what metal should she use for C, for D? And you have to fill that all in. That's short answer. It's easier for me to
You
grade.
get a periodic table on this.
Yes,
Okay.
absolutely. Calculate each cell. Here's a great example. So
D for everything.
in class, you know, in class when we're talking about acid-base chemistry, we're going to talk about autoionization a lot, right? The autoionization of water, KW, all of that. But on the final, what I ask people to do is think about the autoionization of ammonia. So you have to give me an autoionization. You have to create the equation for autoionization of ammonia. Write out that equation, write out the ion product expression, so K ammonia instead of KW. So on the final, you're really asked to like stretch what you've been doing.
I'm already panicking and I'm not in a class.
This is me.
Remember?
Don't, I'm not trying to panic, because the thing is, if you do the work all semester,
Then this is cool.
yeah,
You're good.
there will have been a problem similar to this on the homework, I promise you.
This is why you take the class, guys. They don't just hand you this the first day and say good luck. You will have taken 2 semesters of chemistry before you get to this.
Well, the other thing I want you to know is one of the things that all faculty do, I think, at Emory is we're all, a week or 2 before the final, we're going to post a practice final, right? So before every one of my exams, I post a practice exam. So
Is that way?
And do you go over this practice exam like after and no? Okay.
So I am so glad you asked that question, and let me tell you, so, you know, one of the things that makes it really hard is that there's, you know, with the textbook, there's also something called the solution manual, right?
Yes.
The solution manual. And the problem is that sometimes students they'll be doing their homework and they'll run into a problem, they'll be like, let me just look at the solution manual. Oh, I know how to do it now because I see it in the solution manual. So they work it out from the solution manual. Go a couple problems, they run into a problem, they get the solution manual. I know that happens. Like I see students doing it, like in office hours and things, and I'm gonna come to you in 1 minute. I see them doing it. With my practice exams, I never post a key because if I post a key, I know there's a certain percentage of students who will be doing a problem and say, oh, I don't know how to do this. What did Dr. MacBeth put on the key? And then they'll say, oh, I get it. But they really don't because they didn't come up with the solution on their own. Does that make sense? It's a very fine distinction. So I do not post the key, but what I do is on that Blackboard slide I was telling you about, I create a discussion just for the exam where students can post and ask each other questions. And about 2 days before the exam, there's a whole solution key up there where people have worked out the right problem to every problem, but it's like a back and forth student exchange. So I don't want to shut it down completely because I know students will get together and work on it, but if we do it electronically, everybody has access to it, you know, and if you're really stuck on a problem, and I see this happen sometimes too, where a student will be like, oh, no one's posting on number 15, like on the practice exam. They're like, no one's put up a question about 15 and I don't know how to start it. I'm like, put something up there because no one else knows how to start it either. Like everyone is like, everyone's in the class waiting for someone else. No, they are, honestly. And then the minute that post goes on, like, and you know, a student that I've talked into it, a student will be in my office hours and I'll be like, Jen, just do it. Just put it up there. The minute it goes up, within an hour, 15 people are like, oh, I didn't know how to start it either. And then the back and forth, the exchange of ideas starts, you know, and someone will be like, well, I really think we should go to grams first and then look at electrochemical current. And then pretty soon, someone will, based on the discussion, will figure it out. But I'm telling you, if you don't see something up there, no one else knows how to do it either. They're just shy. For those problems, the only way I get them, like students to post on the really tricky ones on the practice exam, is when they're in my office hours, I'm basically like post, like get the discussion going. And the other thing I want you to know is that we watch those discussions, and someone posts, and no one does it to be malicious or evil, but every once in a while someone will post a completely wrong answer. And we're watching that, and we're like, oh no, don't do that. We're like, you know, and then we'll jump on and say, actually, do it this way.
I just imagine you guys with popcorn, just like, oh my god.
No. But we all, we'll post practice exams and things like that.
Okay.
Promise. Other, you have.
Like if we can be, we don't want to do it, no one else knows, we want you to help it.
Yeah.
Okay.
I do. I really do help.
She is a nice person. They all are. Like they want to help
no,
you.
I'm scared them.
Oh, yeah.
Listen, I've never. This is my last time doing this. Everyone is like, I'm leaving.
I have questions regarding the chemistry major. Do the majority of students that actually major in chemistry, do they start off in like 142 or like organic?
It is perfectly reasonable to start out in 141 and 142. I would say probably over 50% start out in that sequence. I mean, and some people really just want that foundation, you know, because maybe, I don't expect everyone knows what they want to do when they're a first year, right? So some students are like, well, you know, I think I want to do this, I think I want to go to medical school, or I think I want to do an MD, PhD, but I'm not really sure. So why don't I just go ahead and take this sequence, and if it turns out to be not that difficult and you do really well, well, that's nice on your transcript, right? You have 2 good grades in a decent science course. But maybe you, ultimately, maybe your sophomore year you get involved in research, right? And you love research. And then you decide, hey, I want to be a PhD chemist and this is what I want to do. Then you have that solid foundation. Something really funny, this person doesn't teach here. Teaches at a school in California, let's put it this way. Really funny. Someone who started his undergraduate degree, a very dear friend of mine, he knew what he was doing. He was going to med school. All he wanted to do was to be a doctor. He gets involved in research his sophomore year. He falls in love with organic chemistry and decides that he wants to go on to be like a professor, do research, all of that. Great, good for him. Funny thing is, when he was an undergrad, he didn't take 141 and 142, like the equivalent of 141 and 142, because he tested out of it. And then his first teaching assignment that he had to do as a faculty member was 141, 142, and he was like, I haven't taken this for like 15 years. All I'm saying is you never know, right? You never know. You never know.
What's your
Doubling chem
is that a bad move?
No. See, my facial expression was like that because I get this question all the time.
A lot of people do that.
Yeah, a lot of people do it. I think if you have what you feel is a decent background in chem, and you've had bio before, like if you've had chem before and you've had bio before, I don't think there's any reason you can't do it. I have a lot of advisees, I advise undergrads, do perfectly well, you know, with both courses, no problems. I think where it becomes a challenge is that, Drew, and I want you to speak up, because I don't know, I think where it becomes a challenge is if you've had very limited exposure to one of those 2 subjects.
Exactly.
And if you've not had a really solid bio background or a really solid chem background before, doubling up on those 2, it's not impossible. You can definitely do it, no problem, but you really want to carve out enough time. It's about carving out the time that you're going to need.
My other question would be, what is it that you are passionate about both of those, that that's where you want to go, that you want to do the double major. There's no problem in doing it, and we can help you get there. But do you think that it will make you more for this next stage? Med schools will like it, something like that? We can talk to you about that because they don't. But you know, that's, I mean, is it because you want to go into biochem in your master's?
No, I mean like
Taking two courses.
Taking two courses.
Oh, at the same time. Sorry. I think I meant major. Yeah, then that's something we would talk about. It would, just like Dr. MacBeth said, it would depend on your background and where your preparation is. That's what we really want you guys to be thinking about while you're in GLUE. Is what does your preparation look like, and did that look like something that was something you could do? So yeah, your preparation becomes what's really important.
And because I do undergraduate advising, right? That's part of what we do is meet with undergrads and talk to them about courses. I mean, I've had students before who are like, undergrad science majors that are like, I really don't want to take anything else this semester because I'm taking my continuing writing requirement, and like writing is like a huge time sink for me. I've had students that like with calculus were great and writing was really difficult. And so it's kind of like knowing where you're at and what you have to dedicate time to. And it was good that this student knew enough to say, this semester I can't take, I can't pack my schedule because I've got this writing course and I keep not doing well, I need time for it. So it's about knowing where you are and talking to your advisor.
Right. And talking to your advisor especially, and that's the hardest part, is being honest about where you are. We're all at different locations or different parts of the continuum for what we know. And it's just being honest about that and saying, this is what I know right now, my math is not particularly strong. Then I would say, hold off on your chemistry, take your math, take the bio now, something else, so that you would be ready to go into Chem 141 and 142 and get those A's and get solid grades.
Yeah, that's right. And it's just about, and also, one thing that I tell students, especially like first semester, first year, and this might sound as if I'm being overprotective or overly cautious, like that, well, you guys, it's great that you're here, right? Because you're already learning your way around campus and you're figuring things out. But a lot of students don't have this opportunity for exposure. So that first semester, it's like I always caution people, not to be overzealous in the number of courses and things they sign up for, because you have a lot of things to figure out. You're trying to figure out how to drop courses, how to register for courses, where's my PE meeting, what, how is this, I haven't invited, I'm not saying this will happen to you, but sometimes students, you get assigned an advisor and that person you never, you go to their office and it doesn't look like anyone's been there in 2 years, and you're like, this is my advisor, but they're not around. So you've got stuff like that you have to figure out. It's like, the other thing I would say is you have to be your own best advocate. And if you're not getting what you need in terms of advising or help in class or whatever, you've got to go out and look for those resources and, look towards this program to say, just be vocal, because the problem is it's not that we want this to happen, but there are a lot of people, right? We're going to bring in, what, 1,150, 1,200 new students this year. And we want everyone to succeed, but we're not, it's impossible.
It's a lot, again, a lot of you guys, only a few faculty members. So you've got to be vocal if you're not getting what you want. You need to be seeing me, Miss Neal. There's a list of people that we have that you need to be seeing if you're not getting what you want. We make sure that's our job. Yeah.
I have a question about your chemistry background.
Yes.
What particular subfield interests you the most? Like, what was your postdoc?
Inorganic. I'm an inorganic chemist, and I do research in inorganic chemistry. So my PhD was bioinorganic, so basically studying transition metals and biological systems, enzymes, how things like
cool.
how things like cobalt and iron and even manganese are used in enzymes to carry out catalytic reactions. And now here at Emory, what I research is inorganic chemistry still, but basically in catalyst development. So what I've done is I've taken my background in bioinorganic chemistry, studying biological systems, and now what we're trying to do is in the lab make small molecule analogs of those enzymatic active sites and do the same type of catalysis.
So like synthesizing like a natural process?
Yeah. That's exactly right. Now, I will tell you this, my group is mainly all people interested in inorganic chemistry. I did just hire Felicia is now postdocing with me, and she's an organic.
Nice.
She's an organic chemist, and she's doing exactly that. She's using some of the processes we've developed to do the natural products.
Do you allow undergraduates to research in the lab?
We do,
Okay.
yes. Where I always, and right now I have one undergraduate. Do you know Jessica Ellenberg? You do.
Yes.
Jessica Ellenberg.
Yeah,
She's
she's
been
a
with
sure fellow.
me. Yeah, she's
Yeah.
a sure fellow. She's been with me since her freshman year, and last summer. So I'm part of this Center for CH Functionalization. I'm a PI. It's just a big NSF center. Last summer I actually sent her to UC Irvine, so she spent the summer with a collaborator in California doing work related to her project in my lab, but doing it out in California. And this summer she's interning at Homeland Security in DC. Yeah, so she's been with me since her freshman year. So yeah, definitely. And I would encourage everybody to get involved as soon as you can if you're interested in research. Because you get there are a lot more opportunities. You know, the sooner you start, then, I mean, so I'm talking about one student in particular, but the great thing about Jessica was she started her first year, so by the time that she was, after her sophomore year, she had enough experience where I could be like, well, yeah, I'll send her. Like, she knows what she's doing, you know. So more time for more opportunities. I don't know what she's going to do after. I think she's seriously thinking about grad school, but we'll see. Other questions? Great questions. Go ahead.
Okay, like, you told us this and Dr. Culver's told us this too, like if you put in a lot of effort and you do all your assignments, you work hard in class, and like it'll pay off, like you should get a good grade. Is that true? Like, is that really true?
I mean, yeah, so I'm going to get to, yes, I believe that's really true. I believe that if you work really hard and you work like in a smart way, in a right way, it'll pay off. One of the hardest things, and I didn't tell you guys this, when I was introducing myself, I said to Kiwi, my husband, he also teaches at chemistry at Emory, and he teaches organic chemistry. I'm one of the toughest, I'm just going to be honest with you, the toughest things, you know, this May, my final exam was on May 1st, we had it graded by May 3rd. You know, one of the toughest things I have to do as a faculty member is I have a student who I know has been busting their butt all semester come in and talk to me because, you know, maybe, not just one, but this handful of students, maybe they got a C or a C minus, and they are just completely crushed because they worked so hard all semester. But so I'll tell you, most of the time, if you work hard and you work correctly, it will definitely pay off. Where it's really difficult is where students really are working hard, but they're not working correctly. So they invest a lot of time, but they get very little return. That happens. And when I tell students, when that happens, and I'm very honest with students, when that happens, I say, look, you've got to rethink how you're studying. Like, what you're doing is not working. And the other thing to remember is if you find yourself in that situation, the best time to realize it is your first year. Because if you realize it your first year, you can correct. Nothing is insurmountable, right? Like I tell students, a C in chemistry is no big deal. Like lots of very successful people have pulled a C in chemistry at some point in their life. No one's going to look at that. But if it's a flag that you're not studying the right way, what you really have to do is figure out, you know, how are my study habits failing me? I think the hardest transition, and Dr. Cole, you should tell me if I'm getting this wrong. The hardest transition is coming from high school to university and people don't know how to study. But it's not because you don't know how to study, it's because you're all really bright. And so you kind of, with high school, right, you just kind of got it. It really wasn't that hard. I'm not saying that university is hard either. We just move through things at a much more rapid pace. And I think it's one of the hardest things to see is people who get here and realize, oh my gosh, I really don't know how to study. Lots of students are good at being given a certain amount of information and regurgitating it. That won't happen here. What's going to happen here is you're going to be given a ton of information, asked to do a lot of practice problems, and when you go into like the exam, you're going to be asked to basically use that to synthesize new knowledge, you know? Like it's different. It's not just learning and regurgitating. You're going to have to know it all and be able to apply it in a new context. And it's a struggle because you don't know that you don't know how to study. And I'm not saying you don't know how to study. I'm saying that if you feel like you worked really hard, like if for your first exam in chemistry or biology or whatever, if you put in over the course of the time leading up to that, you know, not the night before, let me be clear. Do not spend 20 hours the day before studying, that never works well. But like if you're studying regularly and feel like you're working really hard and that first exam you go in and, you know, maybe you pull a 68 or something, that is the time when you want to say, okay, I'm not studying correctly, like how do I fix this? So the sooner you can fix that if it's a problem, the better. If you're working really hard and you're working smartly, it should pay off. You know, you should be rewarded with the grades. I think. I mean, like,
no, I agree. Yeah.
Go ahead.
I'm almost scared, but what's the average grade in your class?
No, that's a fair question. On the first exam, in-class exam I gave, I think the average was a 68. And so I had 120 people.
Oh, that's great.
No, it's okay. It is okay.
It's okay.
So, wait, you should also tell them that.
Yeah.
I dropped one of the tests.
She drops one of the tests, remember that.
And I will tell you, on the third exam, I think the average was around 76 on exam 3. So it goes up. The other thing is people, you know, like I said, the whole adjusting to college and stuff, the first exams and stuff are always a little rough. People start to realize what to expect, the grades go up. Yeah.
You scale?
I do scale. And I would only ever scale up, not down. But yeah, definitely, we scale. And I always try to get it around, try to get the average, adjust the average so it's around 74, 75.
Which is a C.
Right.
Remember how we talked about C means meeting expectations.
Yeah, that's right, that's right. And so the other thing I would just say is that
We don't like C's.
Like that grade, like you get in touch with reality.
yeah, and the other thing I would say is that so if you look at the average GPAs coming out, you know, maybe there's 6 different sections of chemistry. I think the average grade, like letter grade, is like a CC+.
It's a C+ right now for you guys, yeah.
Yeah.
You said when you grade a test, you have a like,
Team of graders.
Yes. What entails in a team of graders? Like how many people?
So typically, I like to grade with like 2 other people, and I typically take like third year or beyond PhD students, and we sit in a room on a Saturday and we grade all day, you know. And so most people who teach chemistry are really picky about who we choose because we want to understand the material, but people are going to grade fairly and consistently.
Okay, I'm confused about this grading scale because at my school, like it was like 93 to 100 was an A, 85 to 92 was a B, 84 to like a 76 was a C, and then like 69 down was an F, and I think like 70 to like 66 was like, 76 was the D. So I'm confused about how this grading scale is going down.
It's the same, but we run on a 10-point scale.
90 to 100.
90 to 100 is an A. Now, do we do plus minus?
You don't do A pluses.
But we do A minuses. Yeah, 90 to 93 is an A minus.
Okay.
87 to 90 is a B plus.
Yeah.
83 to 87 is a B. 80 to 83 is a B minus, and then you go. So a C plus would be 77.
There's no A plus.
So it's above 93
Is an A.
Yeah.
Solid A.
Yeah. Go ahead.
Oh, so you know how you pay like $70 to access like the ALEC program for like a whole year? Let's say that you take the GCAT, but you don't get like a place in the the class. Like, what would happen? Like,
Yeah, you'll get a place.
you will?
Yeah, I promise you, you'll get a place. So here's something like a
Oh,
super
did you
secret.
know?
That's good to know.
Yeah.
Yay. I did it.
Sometimes, but I don't want you to panic, and here's a little bit of inside information that you all can have. The way that scheduling courses work, especially for chemistry, is that we can't give you a seat in a lecture unless there's a place in a lab for you. So sometimes what will happen is, these guys haven't signed up yet for the classes, have they?
No, I don't. They will soon though because of the new policy, but yeah.
He's not the 29th.
Or is it, no, July 11th is when we begin the enroll process.
Yeah.
It's like 8 hours or something.
Yeah, you get 8 hours of classes guaranteed, and then after that, but you still have to meet with an advisor to finalize that schedule. but you still get to pick up 8 hours.
8 hours. What I was going to say is that because of the way the seats in the lecture are tied to places in the lab, sometimes what happens at the very beginning of the semester when everyone's enrolling, it'll look like all the chemistry sections are closed. And it happens every year where people panic because they're like, I have to get 141 and 140, right? Because otherwise I'm going to be delayed for a year. Everybody who needs 141 and 142 will get 141 and 142, but it might not be, like the seat might not actually open in the class you need until after the semester starts. So what you want to do is you want to be proactive, and if you find yourself locked out of a chemistry section, so let's say that the only section that fits your schedule is Tuesday and Thursday from 11 to 12:15. That's the only one that works with your other classes. But that section's closed. What you want to do is you want to email the faculty member and say, look, this is the one that works for my schedule, I need in this section. That person is going to write you back, and I have like 100 of these canned emails on my laptop that basically say, thanks for emailing me, I've added you to a list, or I'm forwarding you to the director of this course. We're going to add you to a list. Go to the section that fits your schedule, but you might not officially get added until after the class starts. Does that make sense? Because it's a complicated process opening up the lab seats and lecture seats. But you'll get into, we've never, and I'll knock wood, we've never, ever not gotten people in the courses that they need. We just have to open more seats. But you'll get in. Like, yeah, we're not going to charge you, ask you to pay $70 and then
That's what I'm
$70 and then sorry, no seat for you.
Yeah.
next year.
No, that won't happen. Because you need it for so many things moving forward. Other questions? Go ahead.
If you start the semester later, like, would you still have things like graded for you? You know what I'm saying?
Yeah, absolutely. And in fact, we don't do anything until after the ad.
Yeah, no, it
And
doesn't.
ad drop swap. Like there are no quizzes or anything like that. And in fact, the labs don't even start right at the beginning of the semester. The labs, first week of classes and stuff, you won't even really have the lab courses because they're going to be delayed to make sure everyone gets in the classes that they need and things like that. Other questions? Really not trying to scare you. I want you to be excited and to work hard. Yeah. And to let you know that no one else knows what's happening either.
Yeah.
Even though they act like it.
Yeah.
Other questions? Well, what are you most excited? Tell me, what are you guys most excited? Someone, what are you most excited about? What are you most nervous about? What?
Being stupid. Most nervous about being that one person that doesn't know anything.
I'm excited to take a college science class, but I'm nervous about the exam and the amount of material that I have to cover. That's like my overall feeling about it.
Because I'm going to tell you the amount of take home is like if you had 50 questions and Alex and something else, and then his other class is 50 questions and Alex, that's 100 questions.
That's right.
Remember we talked about time management?
Yeah.
Remember that little case study we did? Now it's all starting to fill in.
Well, and that's why I encourage people to start early and do a little bit each day so it doesn't pile up. Oh, and the other thing, if you told them they're meeting someone from biology, right?
Yeah, they'll be with Patrick. Yeah.
Okay. Because we have this really bad habit, we don't do it on purpose, but we tend to almost always schedule exams around the same time, like 141 and 142. We almost inevitably put the first exam the same week. And the students are like, oh.
Yeah.
And it's like, why do you do this? And it's like, well, because maybe we finished 3 or 4 chapters and it seems like the right time. You're like, but I have bio this week. But if you start a little bit in advance, do a little bit every day, it's manageable. But if you wait until that week,
No.
Good luck. Good luck.
It's better for wine, so we destroyed
Well, we do get better for the wine.
I think what we heard constantly is the primary difference between college and high school is the ability to study, right? And how we actually approach material. And you guys have constantly mentioned the fact that there are a vast array of study techniques. And I'm worried about, okay, which one is actually going to fit me and how long is that going to take? Say figure it out. Say figure it out the night before the final. I'm just like, oh. But how long is it going to require?
Yeah, I'm worried that by the time I figure out which one works for me, I'll
It's too
already
late,
be behind.
right?
I'll already have like
But those depend on you, and they depend on the course, and they depend on your preparation for the course. So we can talk to you guys about studying techniques, but it's very individual. If brain mapping works for you, or concept mapping works for you, or flashcards work for you, I mean, muddiest point, there's all different kinds of things that might work for you the best, and we'll talk about them, but you've got to put in the time, and that is the biggest difference between high school and college. High school, they assume you're really not putting in a whole lot of time outside of class. College, we're assuming you're putting in a majority of time outside of class, and that's a big deal. So we talk about the techniques, but you got to find the one that works for you, and that's hard. It takes time.
It does, and no, but that's a great point that you just made. Is we assume you're putting the work in outside of class. So you know how I said, oh, we'll go through a bunch of in-class problems, practice problems. I do it because I want people to get used to working in class and working in small groups. But also, I'll do a handful in class. I mean, and one thing that students always tell me on my evaluations is I do more in-class problems than anyone else.
Yeah.
Like I feel like you've gotta see it, and I've gotta work through it with you. But you know, the thing is, we'll go through a bunch in class, but then there's probably going to be 10 to 15 of those types of problems on the homework. You know, and so it's like I'll show you how to do it in class, but you have to put in the practice so that you get comfortable with it. The other thing I'll tell you about Alex is that I think Alex is an amazing tool, because with Alex, if there are things you're struggling with, you can bet that that's going to map onto what you'll have problems with on the exam. You know, like certain sections, the pie, right? Certain sections or certain concepts, people are like, PV equals NRT, like I got that, I got gas laws. And then they'll run into something where they're like, oh, I'll get emails from people who will tell me, you know, for this one section, I put 2 hours in, and I'm like, well then come see me because you're missing something. You know, because it gets to the point where people are just guessing because it's online, and they're just like, I'm so tired of
There's
this.
no way to beat Alex.
No, you cannot beat Alex.
It's like the same 5 problems, but it changes the numbers every single time.
Yeah.
It's
And
not yeah.
it's highly adaptive, so
I had that
it's
problem
figuring you out.
with the reactants.
Yeah.
It
figures you out. That's his job.
I always feel like I enjoy doing this so much, but I'm really not trying to scare people. I just want people to be successful.
Yeah, I'm really excited actually.
Good.
So do it now.
You're gonna love it now. Let's do it. Let's get them signed up. Let's knock this out.
Yeah, 141.
How
You're
does
good to go.
Yeah.
You're good to go. Like 2 more
Sorry.
minutes. Yeah.
Well, I think,
No, I mean to get them through the class. We'll do it.
Oh, we'll do that. Yeah, that'll work. Yeah.
you know, but I think when it comes to studying, people take too much focus on how to like review. Like you're talking about flashcards, and you're talking about like going back and forth in group work. That's already after you understood.
Right.
Like we're talking about when you're going into that raw, I have no idea what I'm starting, this is fresh to me.
Mm-hmm.
Like I used to do the thing where it wasn't necessarily the day before the exam, but I would just like read it all one day, like just do it all in one day, and it would just not work. And, like,
So this,
Not supposed to.
I'm
The brain doesn't work like that.
I am so glad you brought this
The
up.
person's like, no.
So this is really interesting. From a study perspective, what I tell people is if you're going to do that, so typically my exam, I almost always give my exams on Thursdays because I always teach Tuesday, Thursday.
Do you just like Thursdays?
Well, no, because then I can grade it over the weekend and get it out to Tuesday. But what I was going to say is sometimes students will come see me, right, and I always have office hours on Friday, and they'll be like, okay, exam number 1 is coming up next week on Thursday, and I'm going to read chapters 11, 12, and 13 this weekend, right, because that's the first exam. And then do not do that.
No.
Do not, no. Do not do that, because what you will do is you will spend the whole weekend reading stuff, right? And this is where breaking it down and taking it a bit by bit really helps. So what I always tell students is that, let's say you go into one of my lectures and I cover 4 sections, right? In the textbook, that's really only going to be about 12 pages. And it's not 12 pages full of text, right? Because it's chemistry, so they're going to be pictures and they're going to be practice problems. But after that class, right, if you can find an hour that night, 15 minutes, you can read those 4 sections, right? It's not bad. And in those sections, there's going to be a few practice problems. Do it. And then go to the back of the chapter problems or the Alex problems and nail those, like bang those out. You'll have finished 4 sections. Maybe you spent an hour and 15 minutes, but it's fresh and you will compartment, you would have broken it down into that, like to match what we did in class. That makes it manageable. Waiting until the weekend before the exam and you come to my office on Friday and you say, I'm going to read all 3 chapters this weekend, No, don't do that. Like I'm like, do not do that. Like that is just gonna panic you, literally. Yeah, you confuse yourself. And the other thing to remember, sorry, I'm gonna get to everyone. But not only do you confuse yourself, at that point, the adrenaline's already pumping, right? Like you're already stressed. Sometimes students come to me and they're so stressed out about performing well, it doesn't matter if they understand the material or not, they're not gonna be able to study, right? Because I had a bio test this week, I couldn't study, so I'm gonna do it all this weekend. It's like, okay, we gotta calm down, breathe, because don't let yourself get psyched out. Sorry, there were other questions.
So when you reviewed the fact that you should not memorize, you should understand. Now, okay, I vaguely have an understanding of what that is because my AP physics class are required to understand concepts but memorize formulas. But could you elaborate on don't invest in memorization?
Sure.
What does that mean?
So don't invest in memorization. Because chemistry 50, so one of the reasons I wanted to show you an example of the final is so that you can see that all the exams are split about 50-50, conceptual understanding, kind of multiple choice, how you relate concepts, and 50% problem solving. You're going to have to do short answer or work problems. When I tell you not to memorize, what I mean is we'll be doing, you're going to learn a lot of different concepts, right? So let's just take the chapter on solutions and solubility. Factors governing solubility, right? So gases. Are gases soluble when you increase? So we're going to learn all these different things that impact solubility of different phases in different solvents. So gases, for instance, become more soluble, right, as you decrease the temperature of a liquid solvent. But solids become more soluble, tend to become more soluble as you increase the temperature, right? So here, in both cases, you're making a solution. One, you're dissolving a gas in a liquid, and one, you're dissolving a solid in a liquid phase, right? But two different effects to increase the solubility. Well, you're going to learn about 15 different rules. And what I'm telling you is you need to understand the principles behind those. You don't want to just memorize that the solubility of gases in a liquid increase with decreasing temperature. You don't want to just memorize that because the question that I'm going to pull out on the exam is going to have something to do with the kinetics of molecular motion. Like, why does it, why? I'm going to ask you to explain why gas solubility, I'm not just going to say fill in the blank, increase or decrease. I'm going to ask you to explain why. And it's something we will have talked about, but if you just memorize these key facts, and it's not just me, we'll find a way of asking the question that does not rely on memorization. Because we will expect 80% of the students in the class to be able to say, yeah, gas solubility increases in solution with decreasing temperature, which is the opposite of solid. We'll expect everybody to know that, but the number of students that can tell us the molecular reason behind that, that's where we're going to probe. Does that make sense? And when I tell you not to memorize, it's students, I do this thing in all my classes, like the key concepts before an exam, and I'll give you a bullet list of all the things that you need to understand for the exam. And one of the key concepts, one of the bullets on that list will be, you need to understand how different factors influence solubility, right? And that's a section in the textbook, factors influencing solubility. And students will go and they'll just memorize. They'll make a list and memorize all these different rules, but they won't really understand the reason behind it, even though maybe we talked about it in class. We're going through things at a pretty rapid clip. And so they'll come to me after the exam and they'll be like, but I knew these, but I didn't. And it's like, well, what do you mean? They're like, well, I memorized all of these. And I'm like, but none of these questions ask you just to regurgitate. It was really understanding why. Does that make sense? I don't know if I can clarify it for you, but.
Yeah, I'm not familiar with that as much as I think, college requires.
Yeah, no, exactly.
That's normal.
Yeah.
That's normal.
Not alone in this
Yeah. You will see it.
Right.
Go ahead.
I just had a question. In Chem 141, do you use the same textbook? Is that okay?
Yeah. Yeah, and it's a decent one. I'm going to come here and then go.
When you were talking about like kids like, I'm gonna go home and read chapters, the whole book tonight. Do you want us to like go to class, give the lecture, go home and read it, or do you want us to have read, like we know you're gonna talk about chapter 12, read the first couple sections of chapter 12 so we come to class with like a rudimentary understanding so we know what you're talking about?
I think it's great if you can read it ahead of time, but if you can't, I think reading it directly after is maybe not quite as effective, but almost as good. But just getting it sometime within 48 hours after we've covered
But
it.
it's best to come like prepared for what we're gonna talk about.
But like if you read it beforehand and then you have no idea what you're reading,
Exactly.
what is this?
Right.
Before and after.
You know, we're back to this.
That's true.
Yeah, not sitting in class and not knowing what you're talking about. Just, yep, this is all Mandarin.
Well, and that's right. Right. So you can try to read ahead of time. I love that idea. I think that's a great,
Yeah,
if you
that's-
can. I don't know that it's always possible, or if you're really new to the material, you need someone to introduce it a little bit. But breaking it down into these smaller chunks definitely makes it more manageable. I'll tell you one other thing, one of the reasons I advocate breaking material down into reasonable portions is because, let's say you're working up towards your first exam, right? Let's say it's 141, and maybe you've covered 3 or 4 chapters. After 3 or 4 chapters, there's so many different problem and question types that you can get, right? Like you can imagine. That's probably going to be about 40 different individual sections. There are 4 chapters, 10 each chapter. I think by breaking it down into these smaller little chunks, cognitively, you're going to be able to retain a lot more from studying an hour and a half than you can from reading 4 chapters over the weekend. You're going to remember a lot more if you're just studying that little hour. And then the way that I think it helps students is that then when they see a problem like that on the exam, it triggers, oh, I remember that's associated with this chapter, and I don't remember the exact relationship or impact or whatever, but I know that she talked a lot about this, and it probably most likely has to do with molecular motion or kinetics or something. It just helps you relate back to the general area.
The thing is that like when I'm thinking about, oh, what should I be doing? I'm like, oh, well, if I read this chapter now, then like I could just get it all instead of like breaking it down. Because what if I break down and then like I forget what I'm reading or whatever? I make some sort of like stupid rationalization, I guess. And then really what happens is when I sit down, I prolong it because I'm tired of continuously reading for such a long time that I'm just extending it further. And, instead of staying there for like an hour or 2 hours, I'm there for like 4 or 5.
And you're frustrated, right? And you're frustrated,
Yeah.
and you're defeated.
And
you're like,
sleep deprivation.
And I don't want to start, I see it all the time. Our students are like, oh, if I wait to the last minute and I'm going to do these problems, I don't know how to start them. I'm going to skip them. By the time I get to the 3rd section, they're like, forget it, all is lost. Where if you break it down, I think it's more manageable and you can get help, in the intervals between. So.
Yeah.
During lectures, would you say that most/all professors do, like, would they post the notes they would do on the projector, or would they take a video of their lecture and then post it on their website, or is there any type of tool?
I think almost everyone posts the notes. Will post the notes. I tend not to post my notes until after class. I don't post it before. Post it after. I tend not to take videos. This past year was really interesting because we had so many snow days. So we had, I say it was interesting because I had to cancel class 3 times, right? And so that's basically, close to, it's a whole chapter. It was basically like almost 4 hours. So that got interesting, trying to get things out to people ahead of time. But most of the time, you'll have the notes, you'll have the outline, the homework will be posted before you start the material. Alex will be up and available. Alex, you can't be there. Between, I would say the minimum would be 3 and the most would be closer to 5.
Are your tests cumulative?
Only the final. And I always tell people, we all do this, we tell people exactly what chapters and sections are going to be covered on the exam. And we'll even tell you what homework is relevant. And whenever possible, people will give you a practice exam that is reflective of the material you're expected to know, that reflects the material you're.
So anything that is not on the paper that you gave us that says everything that's going to be on the test, you could assume that you don't have to study?
Yeah. Yeah, and I always allow a little bit of time so people can ask questions, like the class before the exam will say, is everyone clear? What do you have questions on?
Okay, if that night after class when I'm doing my homework and I just still don't understand something, is it inappropriate to come to class the next time we have class and ask, I don't get this? Or should I wait till like you're off?
No, it's perfectly acceptable, and I would encourage you to do it. And sometimes, not everybody does this. I mean, this is one of the things that's interesting. It's not all the faculty are the same. We all do our different things. But like one of the things that I do, and I didn't have a chance to show you this, but like we will cover, let's say on that first day of class, we'll go through 3 or 4 different sections. When you come in for the next class, the first thing I'm going to have you do are 2 practice problems from that previous material. And so that always gives students a chance to say, I didn't get it last time, and I don't get it, still don't get it. You know, like I went home and I tried this and I don't understand. So there will be hopefully there'll be natural opportunities for you to say, yeah, I tried this problem, can you explain it? In the meantime, like in between those classes, there should be an opportunity for you to go to office hours, and I would encourage you to do that as well, like to stop by. The other thing about going to office hours and reaching out is that if something, and I've done this before, I'm just going to tell you, I have done. I'm trying to think of what the topic was that I was teaching that I really confused everybody. And I knew that it was just this past spring because I was rushing, right? Like I really wanted to get through this chapter, and it happens, I'm human, I'm not infallible. I was rushing to get through something. And it's something that I know very well, and I think everyone should just intuit, and that's electrochemistry, because I love electrochemistry. And it works like this, you've got the cathode, you've got the anode, and blah, blah, blah. And I flew through it, and I think I confused a lot of people, right? Confused a lot of people. And I didn't realize that until a student came to me the day after, came to office hours, and basically said, Dr. MacBeth, like, I did not understand the 2 practice problems you did. I didn't understand anything. And this is a student I knew always worked hard, right? And I'm like, oh, okay. So next class, after those office hours, I went in to start with 2 practice problems from the preceding lecture, and nobody got them. And that made me realize I blew that whole lecture. Like, I basically had to give it again that day. And I did because someone came and said, I have no idea. Like, I can't. And faculty need to know that. And that's an opportunity for me to say, we're going to go back over this, because I did a poor job, and it's okay to tell people in a nice way by saying
yes. In a nice way, that's right. Yeah.
Great. Well, I'm glad. I want you all to be excited. You're going to do awesome. You're going to have fun. Right?
Yes.
Yes. Thank you.
Oh, one more thing. Thank you all.
Just like the stuff that we did today with like mole conversions and everything, that's like the earliest chemistry I remember, and that's 142. So what's 141?
You're going to do some of that in, you will do that a little bit in 141. The reason we start out 142 with that reminder of all of that is because we use that the rest of the semester.
Okay.
So like in 141 you cover it, but you don't really use it continually throughout, you know what I mean? You don't use it continually. In 142, that's going to be like the basis of some of the stuff that we do. So we just review it in the context of solutions and keywords. But you will touch on it for sure. Just like the other example of that, something you'll do in 141, but then you'll do again in 142. So balancing redox reactions.
Yeah.
You do that in 141, no problem. And then in 142, we do it again. But in 142, we do it again because we're going to use it to do all these calculations.
Okay.
So, yeah. Okay.
Well, thank you so
Thank
much.
you.